The learning objectives for Lecture 4 are to design variable control charts to analyze a business or manufacturing product, analyze a variable control chart to detect when a process is in control. The reading assignment is Chapter 6, pages 235 to 253. So let's take a look at our problem. The data shown in the table are deviations from nominal diameter for holes drilled in a carbon fiber composite material that's used in aerospace manufacturing. Values reported are deviations from nominal in tens of thousandths of an inch. So here's the data. We took 20 samples, and so each sample has six observations from the drawn from the population. This particular example, he doesn't tell us exactly what the times were, but we can imagine, for example, that every hour we drew 5 samples off the assembly line and measured the diameter of these holes, and we recorded them. So what we want to do, we want to set up the X bar and R charts for the process. Is this process in statistical control? Part B, we want to estimate the process standard deviation using the range method. Part C, if the specifications are at nominal plus or minus 100, what can you say about the capability of this process? Evaluate the process CP value. So what I did is I went in this particular example is from Montgomery, and he had the data in a Excel spreadsheet. So I copied the data over to Minitab, and so although Minitab will just load Excel spreadsheets, you just go to File and Open and select it, and it'll bring it right in for you. Or you can cut and paste and put it in Minitab as well. So to get actually to plot a control chart, you go to Stat, Control Charts, Variables, Charts for Subgroups. Since that's what we have every hour we pull five samples from the assembly line. So we have subgroups. X bar R is what we want to plot here. So Minitab automatically calculates the center line, the upper control limit, and the lower control limit. It plots the X bar chart. It plots the range chart. So here we can see now that we have it plotted, we can sort of analyze it here. Everything looks fine. We're well below the plus or minus 3 sigma levels. The range looks very well. Nothing out of the ordinary here, really. Yes, some normal oscillations due to normal variation, but nothing extreme. So here we would say this process is in control. Part B, estimate the process standard deviation using the range method. So we have a formula for that. It's so the standard deviation here is from the samples we've drawn. So that's R bar divided by D2, and D2 comes out of the table. So here how do we find the range? Well, we can pull that right off the chart itself. So we can on our R bar chart, it's 63.5. We selected subgroups of 5, so we can come over in a row for 5, and we can find D2, 2.326. So we divide these out, you get 27.3 as the estimate of the standard deviation. So let's say the specifications are at nominal plus or minus 100. What can you say about the capability of this process? Calculate the process capability coefficient, CP. So here we can plug in the formula, USL minus LSL over 6 times sigma. Sigma we calculated from the previous part B. So we get 1.22. So this process is capable. Anything over 1 is capable. So this process is in control and is capable of production. We can also get this information from Minitab. If you go to Stat, Capability Analysis, Quality Tools, Normal, and you enter the following information. You select the subgroups. So you click. So this will typically default to single column. the way I have the table set up, if you click subgroups and you click in this little box here, it'll pull up these over here. You can select C1 through C5. Just click here and click there and hit select, and it'll fill them in here. The lower spec and upper spec, we fill those in from the problem. It's minus 100 and 100. If you click on the tab, the options here, so you click on options here, click on the target, it should be 0. And the K value is 6 here. This is a standard. You want the parts per million displayed and the capability stats CP displayed. So when you do that and you select OK, Minitab will plot the histogram for you, and it'll overlay a normal distribution as well. So here you can see our target is 0. You can see our lower specification limit and our upper specification limit. Those are the plus or minus 100s we put in. You get this information over here as well. The target is 0. Minus 100 and plus 100, that's what we put in. It reports the sample mean, how many samples there were 100. It reports the standard deviation, the overall standard deviation from the data, and it also reports the standard deviation within the groups as well. So I've kind of summarized this down here as well, so you can take a look at that reading there. So here the CP is also reported here, 1.25, which we actually calculated. This CP value, as we'll learn in later modules, is what's known as the potential capability. It's not. There's better ways to do it. We'll learn about what's known as the CPK value, which is a better way, is a truer representation of the process capability. Because here you can see this chart shifted over to the right a little bit, right? So here's our target, and you can see that our data is kind of skewed over to the right here. So that's why the CP value is higher than the CPK value, as we'll find out later on. The CPK value is going to take the centering into effect. So that's the problem with CP, is it doesn't consider the location of the process. It indicates the potential, of your process if it were centered, and in this case it's not centered. So there's a little work to do to get it kind of centered here. It also reports in the lower kind of chart. It reports the parts per million that were less than the lower specification limit. So these are for the observed. This is the observed performance here. So here we didn't actually observe any that were lower, but they would show up over here in the observed column. You'll see the parts per million less than the lower standard limit. So that would be the parts per million that fell below the minus 100. We didn't have any of those, so that's 0 there. That's what we observed. And same thing for parts per million above the upper specification limit. And the total is simply the addition of these two numbers here. So that's what the observed column. Now it also reports for the overall performance. This is what this little the column for expected overall. Parts per million less than the standard lower specification limit is the expected number of parts per million that have measurements that are less than the lower specification limit. So these are calculated using the overall standard deviation. This is calculated, averaging all the different samples we took together. That's what that is. And same thing for the upper specification limit. So again, this one and this one adds up to the parts per million total. So we would expect that 212.13 parts out of every million would have problems. Either they would fall outside of the upper specification and lower specification zones. Now the last column here, that column is the within. So this is the comparing within subgroups. So like on the first hour we select 6 tires. What's the odds that looking at the deviation within that subgroup. So again, and then this one plus this one adds up to that one there. So this is all spelled out in the reading, and I kind of summarized it without not reading it to you. You can read over this and see what it says here. So again, the last one is the uses the variance within subgroups. That's what this is expected to within subgroups, rather than the overall variance. And honestly, I probably more look at the overall variance myself when I'm analyzing these kind of situations. There's a lot of data here in both charts. So with the control chart and the process capability analysis, really gives you a lot of information on how to improve a process. No matter what it is, if it's in manufacturing or if it's in marketing or whatever you're trying to look, almost any kind of situation can be. You can use a control chart and a process capability analysis to make it better. That's all of this module, and we'll move into the next module, which looks at control charts for attributes.